Let's take a look at data security control. Data needs a series of controls during processing, exchange, and storage. This requires baseline control, but why? Because the state of data can change, it is difficult to control data with a single tool or technical means. This is the significance of the baseline. In the baseline of the entire data security process, a depth defense system is adopted. As we just mentioned, it is difficult to use a single technology or tool. For example, when we access business data, it might be accessed through a VPN. It's also possible that our clients access data through an external portal. It's also possible that our internal network terminals access our servers through exchange routing. It's also possible that our branch offices access data through dedicated lines. So you will find that the same data can be accessed in different ways or through different paths. It's unrealistic to use only one control measure. And our requirement is that no matter if you come from a dedicated line office or from a hotspot via VPN, whether you directly access the portal website through the internet or access the server from the internal network terminal, the security requirements must be the same. Otherwise, it's easy to form. Because if we are in the internal network, security control might be relatively easier to achieve. If we are from a VPN, the possibility of administrator's security control might be slightly smaller because it's too far away or not inside the company. Its control means or intensity might be reduced. But you will find that in this case, the possibility of bringing in viruses or data leakage from the VPN will be higher, which is a problem. Actually, no matter which direction you come from, the requirements for the path to access data are the same. This is what we call the need for security baseline synchronization across the entire enterprise. And this security baseline needs to be protected in multiple ways and at multiple levels, somewhat similar to the Maginot line. Let's look at the diagram on the right. First, we need to consider whether the data can enter, which is authentication. Through authentication, we can at least verify that this is a legitimate user of my enterprise or an internal employee of my enterprise. This can block many illegal accesses. That is to block illegal users outside, leaving only legal users. Can these legal users see? This is what we call whether they can understand, and then whether they can write, whether they can take it away by copying and pasting, and then whether they can change it. Can they change it? These are all legal users. I have thought of ways to ensure their legality. Access. First, we have screened out illegal users. How to realize the legal access of legal users, and another, if a legal user does something illegal, can he leave a trace? Can we trace it? Or can we audit where the problem is? This is whether it can be denied. So students who have studied security know that this is what we often call 3A authentication, authorization, accounting, or auditing. It is a security system or a set of architectures. It is not to say that a certain function or a certain tool can be realized. This requires a series of operations. This is what we call the depth defense system of the security baseline. So this baseline should be the minimum value in the entire security protection standard. Because if even the baseline cannot be reached, then even the basic requirements cannot be met. How can your security be guaranteed? We have also said before that plans and standards are the best practices for security. The best practice can be done or is recommended to do, but if it must be done, it is the baseline. So the baseline is the smallest part of the entire security standard and security practice. If even the baseline cannot be reached, there will be compliance issues. Therefore, defining a good baseline for an enterprise is really important for enterprise security or data protection. The baseline can be divided into many types, including industry, national, company, or organizational baselines. From the perspective of the country, like USGCB, it is the configuration baseline of the US government. Some students will say that the United States is relatively not so strict in management. In fact, it is not. The US government also has its own configuration baseline and security management baseline. We can compare it. What we use more in our country is equal protection. Different levels of enterprises have different security requirements. If it is a city level, it is generally a second level equal protection. If it is a provincial level, it is a third level equal protection. If it is a national or group level, it is a fourth level equal protection. Of course, this is a generalization, but the basic logic is correct. It is defined according to the importance of the industry and the scale of the enterprise, the security level requirements. Compared with the national security requirements of the United States, the form may be different, but the logic is the same. They all define the level from the national perspective, considering the impact on the country and society. There are also some general principles that all countries adhere to. I won't say what the general principles are for now. I will first say that no matter what evaluation standard, there are some basic requirements such as requirements for prevention, detection, response, and recovery. We are called P2DR, so what is its logic? It is that my PT should be greater than DT plus RT. What does it mean? It is rarely tested in exams, of course. I need to explain it now. This is a technical framework for security is PT, which is what we call defense time. If my defense time for the system is greater than the detection time, plus what we call feedback time, then the system is safe. It's like I'm protecting the system from hacker attacks until I'm breached. In this process, if my time is higher than when I detect a hacker and can make corresponding feedback at the same time, then my system is safe. On the contrary, it's like the hacker hasn't attacked and invaded successfully or collapsed me before I detected and gave feedback, then there's no problem. The real situation is that my detection and feedback time is much higher than my defense time. So we need to use a series of technical means to increase this security. How to increase security? One is to increase the defense mechanism. The more you defend, the longer it takes to breach. Or I reduce the detection and feedback mechanism such as situational awareness or IDS. This is what we call prevention, detection, response and recovery, which is a common design principle in security requirements. The second one is as we just mentioned, from data in processing to data in transmission to data in storage. Its data status will change with the data processing process. At different points in time, its status will change, and it's hard for us to use a technical means. It's unrealistic to handle static data and dynamic data with a technical means. So your technical tools and means also need to be adjusted. So security feels very expensive. The reason is that this data is not constant. There is also an external assumption, the insecure principle, which means that once we consider security, we will assume that the outside is insecure, such as configuring access lists, firewalls, or router configuration firewalls. The access control list always has this sentence at the end, and it is implicit. That is, you can't see it, but it exists in the memory access control list called deny any. That is to say, no matter how we configure this access control, no matter how many lines you configure in front, the last line is always deny any because he thinks the default is insecure. So I default to reject. I think the outside is insecure. These are some common principles for security design such as equal protection or the US government's infrastructure. Then we have a set of reference standards. There is a saying that there is no fixed law. That is, although I have a design including evaluation principles, but sometimes we have to adjust based on ourselves. For example, our data may not be connected to the internet. I am an information island. I have no contact with the outside world. I am just an intranet. Then some internet security requirements may not be needed. So we need to know what the general requirements and standards are. And we also need to think about what parts of these general standards we need to refer to and make modifications and cuts. This is very important because there is something called appropriate security. If we are overly secure, it's like spending a lot of money. but it doesn't play a key role and value. These devices are just there, then it's meaningless. So you have to consider applicability. The book gives an example called the Internet Security Center, a standard of CIS, a security control. He called the top 20 security controls. What did he talk about? That is, as a company, if there is an internet exit or business, we must do 20 controls against the internet. 20 control items are the 20 controls that a company must do if there is internet business. For example, like boundary protection. Your firewall definitely has IPS, including email and web protection. You must have, I won't give examples one by one. You need to know this. It's called the Internet Security Center, CIS. The specific details of the 20 security controls. I don't want to talk about it here because that might be more about configure administrators, but we need to know that there is such a standard. And what are the 20 standards? It provides security based on internet business, and it's rarely tested in exams. What are these 20 items? But we need to know that this is for the internet. It's called the Internet Security Center, 20 spaces. In addition, there is SCAP. SCAP is called the Security Content Automation Protocol. It is actually a general rule mainly for vulnerability scanning. Vulnerability scanning, as we said before, for example, I go to our country's own operation maintenance, this vulnerability library called CNVD. Let's take a look. Called China Security Information Vulnerability Public Network Platform. Then here will be, that is, national level vulnerabilities or often appearing vulnerabilities. He will scan to this vulnerability library. In this case, we understand that this foreigner uses SCAP, which stands for Security Content Automation Protocol. It identifies vulnerabilities and the format of the reports. Using SCAP allows us to understand vulnerabilities, including how they occur, and gives us a general unified understanding. In this case, when we write reports, it is easier for the boss to understand. I might be a security department manager in the Asia Pacific region. When I report using SCAP, people all over the world can see it. This is the greatest value of SCAP, which standardizes security vulnerabilities. Until today, in addition to what we just mentioned, whether it's based on domestic CNVD or international SCAP, I need to refresh and load this page. Let's look at the vulnerability list, which is a national level vulnerability. We didn't open it just now, let's take another look. The far left is the vulnerability naming library we mentioned. It has its own name called CVE, which is a vulnerability name database, and this place is called CVSS, which prioritizes vulnerabilities whether they are high, medium or low and how they should be handled. There is a list for this. This list can discover or perceive vulnerabilities. In addition to the CNVD and SCAP we mentioned earlier, there is also situational awareness. Situational awareness can discover vulnerabilities, which is undisputed. Not only can it discover vulnerabilities, but it can also detect external attack sources. It can detect where the attack comes from and how the threat is generated. This is situational awareness. Therefore, situational awareness can reduce risks. This is very important. Also, whether it's SCAP or CNVD, it's also a communication plan. It can achieve a unified communication language or a unified understanding of vulnerabilities. This way, it's easier to manage. If you have two different statements or two different organizations, one organization may consider it high risk while the other may consider it warm. This is very scary. A SCAP can achieve a unified understanding of vulnerabilities, including the levels we mentioned and the different levels of understanding that need to be hit. Here we mention the framework, which is the security baseline we mentioned, and the basic vulnerability library. So we have the concept of a security framework. We need to establish a universal network security management activity, which means how to manage this network, what management strategies and technical solutions are needed, and what security requirements need to be considered during operation and maintenance and later use. In this way, we understand the input and output, the overall system security control, and have a top-down perspective. Let's look specifically at what this security architecture must do. The first is how to protect data in storage. Data in storage in our entire security architecture is also called static data because the data in storage has already formed files. These data are basically encrypted with the AES encryption algorithm, which is symmetric encryption. What is AES? It's called Advanced Encryption System or Advanced Encryption Standard. This is a popular symmetric encryption method for static data, but for mainland China, AES may not be very practical because it is a foreign algorithm. Our country's symmetric encryption algorithm for enterprises or businesses is called SM4, which stands for Commercial Symmetric Encryption Algorithm. Commercial Secret Version 4. This is our country's symmetric encryption algorithm. Why do we need to encrypt static data or data in storage? There are two aspects. On the one hand, hackers can see this data or information, which creates corresponding risks. On the other hand, some data has permissions, right? If you don't meet the permission requirements, or you're not the owner, not the corresponding level person, people who are not authorized by the owner can't see it. So for static data through encryption, we can protect it first, not let others see it. And second, you don't have permission to see it. This is for static data. Oh, why use AES? You need to understand that, as we emphasized earlier, it is symmetric encryption. The characteristic of symmetric encryption is that the encryption speed is fast and the strength is high. In fact, many systems have AES encryption. For example, for Windows, Microsoft's operating system, when we open the resource manager, I randomly find a hard disk service, you right click, there is an option called enable BitLocker. So when enabling BitLocker, the underlying layer of BitLocker is the AES algorithm. Please note that I just turned it off during the encryption process. Don't enable BitLocker casually, as it may cause the hard disk to be encrypted and then the key can't be found or lost, making the hard disk unusable. So just take a look at this. Unless you have professional training and understand BitLocker, we use BitLocker for testing or practice. Be careful and don't use this password on other systems. That is to say, for encrypted files, you must use a symmetric key to decrypt it. But for different business data or different files, we try to use different keys to prevent what? To prevent brute force attacks. What is a brute force attack? Because the username and password are also saved in the form of a database on the server or system. If all your business systems use the same password, say a business system, its security level is not enough and the user password is leaked, it may lead to hackers using this leaked user password to log into other systems to guess, which is a big risk and is not acceptable. So when we use a key to encrypt the password, this key should not be used for other operating systems, or it may be used. This is static data. We also talked about the key of static data, which is usually a combination of numbers and letters, including special symbols. Especially like letters need a mix of upper and lower case. This is what we call a standard for generating keys, a standard for generating keys. Well, password keys can also be used in wireless connections. The development of Wi-Fi has actually gone through 3 generations. The first generation, we used web. The reason it was phased out is because its key generation and management are not secure enough. With the current computing power, we can calculate the web key within a minute. In this case, the data you transmit in the air can be cracked and is not secure. Now we use the WPA2 method. WPA2, called Wi-Fi Protected Access version 2, uses the CMP protocol. It is called Counter Mode Cipher Block Chaining Message Authentication Code Protocol. This cipher block chaining message authentication code protocol uses the AES algorithm. As we mentioned before, the AES algorithm is relatively safe among the current encryption algorithms. It uses a 256-bit key for static data encryption. For Wi-Fi, it uses a 128-bit key. Because Wi-Fi is a terminal, including AP, it needs to consider cost effectiveness when encrypting and decrypting. So the cost should be lower. So 128-bit key is used, but it is enough to ensure the security of the encryption algorithm because it is like this. This counter mode cipher block chaining message authentication code introduces an initialization vector in the process of password encryption, which is equivalent to cutting a complex or large data into several pieces. When I transmit each piece of data, I encrypt it. The ciphertext of the previous piece of data after encryption serves as an input for the next data block. In this case, the key itself has not changed, but because the ciphertext of the previous password block serves as an offset for the password key in the encryption process of the next password block, or increases the difficulty of cracking the key, we can understand it this way. It's like I did a mix or expansion on the original key technology, so the strength of the password and the security of the key have increased. So AES, which is used by C3MP, and WPA2, which we call Wi-Fi protected access 2, are still very difficult to crack. Of course, with the increase in computing power, whether it can be theoretically cracked in the future is not easy to say, but for now WPA2 is relatively safe, and there is already a third version of WPA, which is WPA3, but currently we use WPA2 more often. So this is about the security we need to consider when using and transmitting data.